Amazing day. So for today, we're going to have solving word problems involving polynomial functions. What will be our goal for today? It is to solve word problems involving polynomial function. So among career professionals, the ones most likely to use polynomials on a daily basis are those who need to make complex calculations. For example, an engineer designing a roller coaster would use polynomials to model the curves, while a civil engineer would use polynomials to design roads, buildings, and other structures. Polynomials are also an essential tool in describing and predicting traffic patterns, so appropriate traffic control measures such as traffic lights can be implemented. Economists use polynomials to model economic growth patterns, and medical researchers use them to describe the behavior of the bacterial colonies. So these are the essentials, no? Career professionals who use polynomials, no? To make complex calculations. So polynomial functions have varied applications to real-life situations. As I have said earlier, so the first one that we have for today as a problem is Carl Benedict, the president of Math Club, proposed a project to put up a rectangular math garden whose lot perimeter is 36 meters. He was soliciting suggestions from the numbers of the feasible dimensions of the lot. So suppose you are a number or a member of the club, what will you suggest to Carl Benedict if you want a maximum lot area? So at the end of this activity, were you able to answer the activity? So let's have the solution to the problem. Since perimeter is equal to 2 length plus 2 width, then 36 is equal to 2L plus 2W, or 18 is equal to 1 plus W, and W is equal to 18 minus L. So the lot area can be expressed as A, the A of A of L rather, is equal to length times 18 minus the length, or the area is equal to 18 times the length minus length squared, which is equal to negative, no, length squared minus 18 times the L plus so this will be if we're going to have, no, in vertex form we have a negative 1 minus negative length minus 9 squared plus 81, so that is in vertex form. So therefore, no, getting the value, or getting the value of L, so we have the length as 9 meters and the width as 18 minus the length, wherein we have 18 minus 9, so the width will be 9 as well, so yielding the maximum area of 81 square meters. So what else? So find the length of the edge of a cube. If an edge is increased by 3 decimeter, another edge has a 6 decimeter increase, and the third one decreases by 2 decimeter. So results the 100% increase of its original volume. So what will be our representation? So x plus 3 will be the first edge, plus 6 is the second edge, x minus 2 is the third edge. So the volume of the cube is equal to x cubed, and it increases 100%, or it is doubled. So we can have as x plus 3 times x plus 6 times x minus 2 is equal to 2x cubed, since it was increases 100%, or it is doubled. No? So we have x plus 3, then multiply x plus 6 and x minus 2 first. So we had x squared plus 4x minus 12, so which is equal to 2x cubed. Then so deriving, no, so we have x cubed minus 7x squared plus 36, and that is equivalent to 0. So the use of synthetic division to find x. So let us take 3 as our divisor. So we have bring down 1. 1 times 3 is a positive 3. Negative 7 plus 3 is a negative 4 times 3. That is a negative 12. 0 minus 12 is negative 12. Negative 12 times 3. It must be a negative 36. So we're going to have 36 minus 36 is equal to 0. Therefore, positive 3 is a factor. No, it's a 0 of the equation. So what are the factors? So we have x minus 3 times x squared minus 4x minus 12. No. But x squared minus 4x minus 12 is still factorable. So we got x minus 3 times x minus 6 times x plus 2. So what are the zeros? So we have 3, 6, negative 2. Negative 2 is not acceptable solution because when substituted will result to a negative dimension. So this is considered an extraneous root. Substituting x equals to 3 to the edges, so the dimensions will be 6 by 9 by 1. If we use x equals 6, then the dimensions will be 9 by 12 by 4. So in your self-learning module, you need to answer number 17 to 20, wherein you have trisomy, a gymnast, dismounts, then even parallel bars. Her height depends on the time that she is in the air, as h equals negative 16t squared plus 8t plus 8. So you are about to answer how long it will take trisomy to reach the ground, and will trisomy be 8 feet above the ground? Another thing to answer is to answer and analyze task 4. So you're about to use a sheet of old cardboard or old pieces of plywood, if it's possible or if it's available, as sample materials in preparing an open top box. So with the dimensions below to help Cassidy in arranging her cactus. So the bottom of the box shall be closed. Use the rubric below in doing tasks, then answer the question in your answer sheets. Cassidy need an open top box to display her cactus collections. The open top box can be created by cutting squares from the four corners of a 20 centimeters by 30 centimeters piece of cardboard. Then what dimensions of the box will create an open top box with a volume of 1008 cubic centimeters? Then how will I rate you? So it depends on our rubrics. So 4 points if we have the complete and appropriate solution. So accurate conclusion supported by valid evidence and reasons appropriate to this problem. What else? Number 3, we have an appropriate solution process that is almost complete. Inaccurate but logical conclusion supported by evidence and reasoning but incorrect due to a minor functional error in details of problem, in computations, or in recall formula, etc., or just a minor problem. Then you will get 2 points if you have an appropriate process that is partially complete. Inaccurate but logical conclusion that overlooks or get wrong significant facts about the problem, the rule, computation, etc. And then you will get 1 point if you have an inappropriate process or no evidence of process. So inappropriate conclusion that's supported by facts and logic, or there is no conclusion at all. So the criteria for rating the output. So the box has the needed dimensions and parts. The box is properly labeled with the required length of parts. The box is durable. The box is neat and presentable. So 4 points if you have all the items in the criteria evident. 3 points if you have 3 of the items are evident, 2 points if you have 2 of the items evident, and 1 point if any of the items are evident. And then you're going to have the journal notebook, and then you have another entry. Then just need to reflect, no, and answer the following questions. How can we determine the end behavior of a polynomial functions? So you can use the base as basis, the table that we have in the self-learning module. Then how would you describe the end behavior of the graph? And then what new strategies do you discover in graphing polynomial functions?